Hey guys, welcome to another Leetcode video. Today we're going to be taking a look at a question that's called remove duplicates from a sorted list. So for the problem definition, we've been told that we've been given a head of a sorted linked list. Delete all duplicates such that each element appears only once. Return the linked list sorted as well. So we have a couple of examples down here. Of course, we'll take a look at a deep dive in the conceptual overview and as we also solve the problem. But the one thing to note is that this is a linked list, so it's not like an array or anything. So each node points to like the next node, and I'll explain that more in detail once we get to the conceptual overview. But this is just a quick overview of the question and what we're actually going to solve. So let's jump into it. Okay, so I've written down the problem in my own words, which is what I have as a first comment up here. So I've said that we are writing a function that takes in a sorted linked list and removes any duplicates that exist and returns that linked list sorted. So we have a couple of examples down here. So the first one, we're given a list that has 1, 1, and 2, and what we should return is 1 and 2 because the duplicate here is 1. And then for the second example, also pretty straightforward, is that we have 1, 1, 2, 3, 3. The duplicates are 3 and 1, as you can see right there. So what we should return is 1, 2, and 3. Okay, so this seems pretty straightforward, but one thing that we should understand is that this is not any ordinary list. This is a linked list. So a linked list works in such a way that each of the elements in the list is represented in the structure that we have here, which is a list node. So assuming that we have this 1, for example, the way that we represent this one is that we have the actual value, which is the number itself. So 1, 2, 3, 4, 5. And then we have a pointer to the next value, which is what this dot next represents. So in this case, for this one, the next value would be this one that we have here. For this one, the next value would be this 2 that we have here. For this 2, well, we don't have any other value in the list, so we would point to undefined or null. Okay, so that's exactly how a linked list works. And it's called a linked list because each of the elements in the list is linked to one another. And in this case, it's a singly linked list because we are linking it in one direction. So 1 points to 1, which points to 2, which points to null. Yeah, so that's exactly how a linked list works, and that it's kind of different from an array. Maybe I'll do another video to sort of take a look at the difference. But now taking a look at the actual problem, how exactly do we establish if we have a duplicate or not? So one thing to note is that we've been told that this is a sorted linked list, which means that essentially if we find a duplicate right here for this number 1, for example, we won't find it anywhere else if the next number after this 1 is 2. Simply because the list is sorted, therefore we can't go from 1 to 2 and then back to 1 or something of the sort. So we always know that if we are going to find a duplicate, then those numbers are probably going to be next to each other. So if the duplicate is 1 in this case, 1 and 1 is going to be next to each other. There won't be a scenario where we have, like, for example, 1, 2, and then 1 again. So that's important to note because it's going to help us to solve this problem. Now what we can do is essentially for each of the elements in the list, we can check the next element and see if the values are the same. If the values are the same, all we have to do is just to eliminate that second element from the list, and then we remain with the first element. Then we go ahead and we compare that again to the next element, and if they're not equal, then we just compare now this second element to the next element, and so on and so forth. And then in the end, we end up with the list that is free of any of the duplicates. So that's essentially how we're going to solve this problem. I have a couple of pseudo steps that we're going to follow, but that was the conceptual overview. Okay, so the first step that we're going to go through is we are going to start looking for duplicates from the first element that is provided. So in the function we're provided with this first element, which is the head, and we have access to all of the other elements because we have that next variable. So if we're given the head, we can essentially go to the next element by just saying head.next, which we're going to see. So the next thing that we are going to do is we're going to check out the comparison element, which is going to be the element that's at the next index. So for example, if we're at this first index, we're going to compare it with this next one right here. If we have a comparison element, the current element's next, see if its value is equal to the current value. So we'll compare them and see if the values are equal. Okay, so if the values are equal, we're going to set the next of the current element to be the next of the comparisons element. So let me just try and clarify that. In that case, the current element would, for example, be this one. And then the comparison element would be this next element that we have right there. So we're going to say if these two are equal, then we're going to say that this first element points to the next of that comparison element. So essentially that's how we remove that element that we have in the middle to point to what we have right there. Okay, so how about if they're not equal? So if they're not equal, remember that we can have duplicates of the other numbers. So essentially what we're going to do, so assuming that we have something like this, we're just going to check this 2 and see if we have an element to compare it with. So in the case that we'd have like something like this, then we'd compare this 2 to this 2 that we have right here. And then we'd essentially do the same process. And then in the end, we're just finally going to return the head that we are provided with. And in that case, then we would essentially have something like this if we were provided with the list that we initially had, which is 1, 1, 2, we'd return this. Because essentially we are going to be resetting the values that we have inside the list. And then finally we'd have something like this. Okay, so these are our pseudo steps. We're going to start off by looking for duplicates from the first element. So we're going to define what the first element is. I'm just going to name it current, and then I'm going to set it to the head. Okay, so in this case would be 1. So that's what this would be. Okay, cool. And then now we're going to say that I'm going to do a while loop. So essentially, while some condition is met, we're going to do these operations that we have down here. So what we're saying is that if we have a comparison element, or if we have the current element, so what we can say is that if current is not equal to null, so essentially what we're saying is that as long as we have the head provided, so if the head was not provided, then essentially there's no operations that we can do because we don't have anything to compare it with. So if we have the current element, or if the current element has a comparison, so that would be current.next, is also not equal to null, then we're actually going to perform these actions that we have down here. Okay, so let me just reiterate. The comparison element, as I said, is the current element's next. So this element that we have here is really this element's next value, according to the linked list structure that we saw earlier in the video. So essentially, to get to this next, in order to compare the two, this would be equal to this is next, which is what we've done here. So if we have a current element and then we also have the current.next, which is a comparison, then we'll say that we're going to do the operations that we have down there. Okay, so we're going to check if the values are equal, set the next of the current element to be the next of the comparison element. So Here we're going to say, I'm just going to make it simpler, I'm just going to store a variable that says the comparison, and then what I'm going to store it as is current.next. By the way, I'm not that confident about initializing variables inside while loops, but I think for the sake of this video, I'll just keep it like that. So essentially what we're going to do is to check if the values are equal. So if current dot val, which is what we have right here, so we're checking the value of the current element in the list. So if that value is equal to the comparison dot value, what we're going to do is we're going to set the next of the current element to be the next of the comparison's element. So we're saying that the current next is going to equal comparison dot next. Okay, so let me clarify that a bit. In the case that we have this example that we have right here, where we have 1, 1, and 2. Okay, so in this case, we do have a current and we do have a comparison element. So we're essentially saying if 1 is equal to 1, so if this 1 is equal to 1, what we're going to do is we're going to say this current.next, which is this 1, is equal to this comparison.next, so which is 2. So essentially what we're saying is that we're going to remove that 1 that we had right there, and then now we're going to just be left with 1 and 2. So that's what's happening right here, where we say current.next is equal to comparison.next. Okay, so if the values are not equal, set the current element to be its next element and proceed with the comparison. So if they are not equal, what we're going to do is we're just going to have an else block, and I'm just going to put it down here as a comment. So what we're going to say is that the current dot next is equal to so we're going to say that the current is equal to current dot next. So essentially what we're saying is that if these two values are not equal, so assuming that we had something like this, for example, we would say that this 1 is not equal to this 2. So essentially we would land on the else block, we would avoid this code that we have right here. So we're going to say that the current element is now equal to the next element, so which is 2. So assuming that we started with this as a current, so that's the current value that we have, which is this 1. So we pass through it with this while loop that we have right here. We realize that the values are not equal, so we come here and then we just go to the next value. So the current is now equal to this 2 that we have here. So now we compare 2 and 2, we come, we land here, we say that the current.next is equal to the comparison.next. So the comparison.next is just null, so we don't have anything that we have there. Okay, so I hope that this makes sense. And then finally, after going through each of the elements in the list, we're just going to return the head. Okay, cool. So I hope that this makes sense. Now what we're going to do is let's try and run through the function with this provided list that we have right here. Okay, cool. So now that we have that list, the first thing that we're doing here is we're saying the current is equal to the head. So that's the first element that we are provided with right here. So we're saying that C, so that stands for the current, is at 1. Now we're coming here and then we're saying, well, while the current is not null, so of course we have that 1, and while the current.next exists, so we have a next as well. So while that exists, we're going to set the comparison to be the current.next. So we'll say that that's the comparison, CP. And then we'll say that if the current val is equal to the comparison.val, so if 1 is equals to 1, we're going to say the current.next is equals to the comparison.next. So essentially our list now looks like this. okay, because we've essentially eliminated what we had right there. Cool. So now what we're going to say is that because we're not going to land in this else block, we're now going to come back, and then we're going to say that this current now compared to this 2 that we have here, because this condition is still met. We have the current on next, which is what we just set to 2, and then we also have the current. So in this case, we won't land in this first condition that we have here. We'll land in this else block because 1 is not equal to 2. In that case, we're just saying that the current is now equal to the current dot next. So now the current is equals to this 2 that we have right here. Okay, now we go to the next. Again, we compare 2 and 3. We see that we land back here again. So the current is now 3. And then we come here and then we land to this first one because we're comparing this 3 to this comparison that we have here. So now the CP is right here. So we compare 3 and 3 and we notice that, yeah, okay, so we set the current dot next to be the comparison dot next. So now we have something that looks like this, 1, 2, and 3. And then obviously our comparison is at 3, what we have right there. Okay, so finally we won't land into this while block because we do have a current. Well, we do have a current, but we don't have a current on next because current on next of 3 points to null. So there's essentially nothing that we have there. Okay, so in that case, we're now going to return head, which is going to be this one that we have here. So that's going to be the head. And in that case, if we take a look at 1 points to 2 points to 3, in this list, we do not have any duplicates. And that's what we return. So that's essentially how we solve this problem. I hope that it was informative enough and that you guys were able to understand it. Now we're going to paste this code in on Leetcode and then we'll discuss the time complexity. Okay, so I'm back on Leetcode and I'm just going to paste in my code right here. And then I'm just going to click on run code. So that works, and then I'm going to submit. Okay, so that seems that it all works. So for the time and space complexity, the time, we can essentially say that this was O of n. And the reason why this is O of n is because as the input size increases, we essentially have to make comparisons for each of those elements based on the number of the elements that are in the linked list. So if the linked list increases in the number of elements that we have inside it, we shall do more comparisons. So that calls for more time complexity. And then for the space complexity, essentially what we're saying is that this is O of 1, because we didn't use up any space while we were doing this comparisons. So we didn't store like the values of the head anywhere. I mean, we could say this comparison right here, but we're not really storing values based off of the input that was provided. So in this case, we just use a space of O of 1. So that's an analysis of the time and space. I hope that you guys enjoyed this video and you found this informative. Like, share, and subscribe, and I will see you in the next one. Every time